Hey everyone, welcome back to another video on permutations and combination. Today we're going to talk about the questions from year 2012. Let's see the first one. Seven friends together with their respective partners all meet up for a meal. To commemorate the occasion, they arrange for a photograph to be taken of all 14 of them standing in line. Okay. How many different arrangements are there if each friend is standing next to his or her partner? All right. So basically, you have part A. You will have seven groups. One, uh, actually, wait, hold on. One, two, three, four, five, six, seven. Seven groups because all the seven friends want to stand with their partner. So you have two, 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 2 factorial, 2 factorial, 2 factorial, 2 factorial, 2 factorial, 2 factorial, and 2 factorial. So all of these combined will give us the net possibilities. So these are 2 factorial and raised to power 7 basically. And since there can be, obviously these are 7 units by themselves, so they have 7 factorial ways of rearranging the groups themselves. So 7 factorial times by 2 raised to power 7, because 2 factorial is just 2. So this would be 645, 120. How many different arrangements are there if 7 friends all stand together and all the partners stand together? Okay, so again, you then have two groups of 7 friends, 7 partners, and since these are 2 different groups, they can have their own arrangements. So 2 factorial times by 7 factorial times by 7 factorial. So this would be 2 times by 7 factorial times by 7 factorial. So this would be 50803 Part B. A group of 9 people consists of 2 boys, 3 girls, and 4 adults. In how many ways can a team of 4 be chosen if both boys are in the team? Okay, all right. This is fairly straightforward. So you need a team of 4 people, and both boys are on the team. So you have 2 boys. So that means you have 3 girls and 4 adults left to choose the 2 spots from. So you will have, sorry, because the process could be random, we just have 7C2 basically. Because they do not put any restriction that we have to have 1 girl, 1 adult. So basically 7C2, this is 21. The adults are either all in the team or all not in the team. So there are 2 possibilities, whether they are in the team. So adults in the team. So when the adults are in the team, you have like 4C4 basically. This would be 1. Now adults not in team, you have the rest of how many? 2 and 3. So 5C4. So 5C4, that is 5. So total ways, I think we can just do this now. So total would be 1 plus 5, that is 6. Okay. At least 2 girls are in the team. So that means there could be 2, there could be 3. So uh, two possibilities. So you have two girls in team. So then you have the rest of, again, how many people? So the next weird thing we're choosing from are the boys and the adults. So six people, 6C2. Okay. And since we have two girls, so obviously we had three girls, so three out of two girls are there. Now, three girls in team. So you will have obviously only one person left to choose from. And since they are all three over here, so 3C3. So this will be 6C2 times by 3C2. This will be 45. And 6C1 times by 3C3. This would be 6. So total would be 51. Straightforward. All right, let's see the next question. An English examination consists of 8 questions in part A and 3 questions in part B. So let's highlight that. Oh, sorry. 8 questions in total. Candidates must choose 6 questions. Okay. And the order in which these questions are chosen does not matter. Find the number of ways in which the 6 questions can be chosen in each of the following cases. A chosen question. Okay. There are no restrictions on which questions can be chosen. Okay, so that means we can choose as from 8 and 3 only 6. So no restrictions. So 8 plus 3 is 11, 8, 11C6. So this would be just simply 11C6, 462. Candidates must choose at least 4 questions from part A. So again, you have a choice. You 4 cues from A, then you have 5 cues from A, and you could have 6 cues from A also. So we need to see this. So if you're choosing 4 questions from part A, you will have 8C4 for the 4 questions in part A, and 2 questions from part B, so 3C2. 5 questions, so 8C5, 3C1, and then 8C6 times by 3C0. So we just need to find the values. 8C4 times by 3C2, 210. 8C5 times by 3C1, 168. And 8C6 times by 3C0, 28. Total would be just simply the sum of all of these. So 210 plus 168 plus 28, so this would be 406. Candidates must either choose both question 1 and question 2 in part A or choose neither of these questions. Okay, all right. So we again have questions 1, 2 from A selected. So this would be, okay. So if 2 questions are already selected, we need the rest of the 4 to be selected from how many? 8 plus 3, 11. So 2 are already selected, so 9C4. And question 1 and 2 from A, not selected. So this time, selected. This time all 6 are going to be selected, so this is going to be 9C6. So 9C4 plus 9C6, this is going to be 210. That's it. All right, let's see the next question. In how many ways can all the letters of the word telephone be arranged in a line if the letters P and L must be at the ends? Okay, so first off, we need to see how many uh, duplicate letters or duplicate letters are there. So you have three E's, sorry, and nothing else. Okay. So P and L must be at the ends. Okay, so again, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So either P is here, L is here, or P is here, L is here. So, and P and L were occurring only one time. So that basically means that there are two possibilities. That means 2 factorial times by the rest of the 7 factorial. And among them were the three duplicate E's, three identical E's. So 2 factorial times by 7 factorial divided by 3 factorial. So this is 1680. How many different selections of 4 letters can be made? Selections of 4 letters can be made from the 9 letters of the word telephone if there are no E's. Okay. So if there are no E's, that means you are selecting from T, L, P, H, O, N. So 6C4, this would be 6C4, 15. If there is exactly one E, okay. So there is exactly one E already selected, E, but for the rest of the 3, you are selecting from T, L, P, H, O, N. So that means 6C3. So this would be 20. And if there are no restrictions, okay, so if there are no restrictions, there are going to be multiple possibilities. So depending on the number of E's. So E's, so you can have, oh, my bad, 0 E's, 1 E, 2 E, and 3 E's. Now we will see the combinations themselves. So if there are 0 E's, we already figured out over here, 6C4, this was 15, this was 6C3 equals to 20, this would be 6C2, 6C1, because 3 E's are selected over here. Now we need to sum these up, so 6C2 is also 15. Oh, and 6C1 is 6. So for a question like this, what you could have done is use the sigma operator on the calculator. So 6Cx, where x goes from 1 to 4. Because 6C1, 2, 3, 4. So how you can actually do that, you will have something on your calculator like this also. Upper limit is 4, lower limit is 1, and the function is that this is 6Cx, 56. And basically if you add these up, so 30, 30, 15 plus 15, 30, 30 plus 20, 50. This is also 56. Okay, all right, so let's see this one. In a sweet shop, 5 identical packets of toffees, 4 identical packets of fruit gums, wait a second, and 9 identical packets of chocolates are arranged. So the key word over here is identical. So these are identical items. 5 identical, oh sorry, no, this was also, okay. Find the number of different arrangements of the packets that are possible if the packets of the chocolates are kept together. Now, remember, these are identical pairs of toffees. So toffees, there are 5. Fruit gums, there are 4. And chocolates are 9. And chocolates we want to keep together. So we have 9 plus 9, 18. So 80. Um, how many places would this become? Actually, we can actually see that. So 5 plus 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10th can be the chocolates group, in which we have 9 chocolates by themselves. And they are all identical, by the way. So 10 things we have, 10 groups, out of which you have 5 identical toffees, 4 identical fruit gums, and the 9 group that you have, they are also all identical. So basically, we didn't actually need that, but for thorough practice, 5 factorial divided by 4 factorial, so 1260. Okay, so B part. Jessica buys 8 different packets of biscuits. Okay, now there are different packets of biscuits. She then chooses 4 of these packets. How many different choices are possible if the order in which Jessica chooses the 4 packets is taken into account? So that would be just simply 8p4. You could also rewrite it as you have 1, 2, 3, 4, 8 choices for the first one, 7 choices for the second one, 6 and 5. So both of these would be identical. So 8p4 is 1680. Nine different fruit pies are to be divided between 3 people so that each person gets an odd number of pies. Find the number of ways this can be done. 9 different fruit pies are to be, okay, all right. So basically we need a list of possibilities that we can get. Okay, so let's make a list of possibilities. We have 3 people. So let's say person A, person B, person C. So the choices would be, for example, 1, 1, 7. We increase the B one by one. So 1, 3, 5, then 1, 5, 3, 1, 7, 1. Let's keep on going. Then we have 3. Then the possibilities are 3, 1, 5, 3, 3, 3, 3, 5, 1. Is there any possibility with 7? No, no, no. Okay. So 3, 5, 1. Okay. Then for when this becomes 5, 1, 3, 5, 3, 1, and 7, 1, 1. So let's count the possibilities because the combos that we have 1, 1, 7, 1, 3, 5, and 3, 3, 3, they will yield the same values no matter how many we have. So 117, 171, 711, sorry, they will give us the same value. So we have 3 times by, what was it? How many? 9 C1, then 8 are left, and then 7 are left out of 7. Now, 135 case. So 135 is repeating once, two times, 3 times, 4 times, 5 times, and 6 times. Okay, so 6 times by 9C1, 8C3, and then 5 are left, 5C5. There's only one 3C3, so 9C3, 9 minus 3, 6C3, and then 3C3. So we just need to total these values. So let's find out the individuals. So 3 times by 9C1 times by 8C1 times by 7C7. So this is 216. Then we have 6 times by 9C1, 8C3, 5C5, 3024. And this one would be 9C3 times by 6C3 times by 3C3. So this is 1680. So we just need to add these together. So 216 plus 3024 plus 1680, 4930. And that's about it. All right, so let's move on to the next question. A team of 3 boys, 3 girls is to be chosen from a group of 12 boys and 9 girls to enter a competition. Tom and Henry are 2 of the boys in the group. Find the number of ways in which the team can be chosen if Tom and Henry are either both in the team or both not in the team. Okay, so this is quite straightforward. We have seen the case in this video alone, like twice at least. So Tom, Henry in the team. So if they are in the team, you need 1, 2, 3 B's and G's. Okay. So Tom and Henry have already been selected. So for the third boy, you need from 10C1, sorry, 10C1. And for these 3, you can have 9C3. Simple, straightforward. So 10C1 times by 9C3, so this is 840. So now the Tom, Henry not in the group, not in the team. So if the Tom and Henry are not in the team, that means you're still selecting from 10, but you're selecting 3. And then there is no restriction on the girls, so 9C3. So you have 10C3 times by 9C3. So this is this. All right, now the total would be simply just the addition of these, or the sum of these. So it's 840 plus, this would be 10920. Okay, now the back room of a cinema has 12 seats, all of which are empty. The group of 8 people, including Mary and Francis, sit in this row. Find the number of different ways in which they can sit in 12 seats if There are no restrictions. Okay, so if there are no restrictions, so let's sketch it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this is the first part. Now there are no restrictions, but there are 8 people. So that means there are 12 possible places for 8 people. So this is just 12p8. No brainer basically. So 9, 9, 5, 8, 400. Mary and Francis do not sit in seats which are next to each other. So do not sit in seats which are next to each other. Okay, all right. So basically, they have alternate seats or different possibilities between. So what we can do over here, a simple way to do this, because there is like 12 possibilities for them, like choices for them to sit. So what we can do over here, we can easily do this by finding the number of times or combinations, oh sorry, arrangements when they are together. So Mary, Francis together, we can consider them to be a group for the time being. So this would become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 possibilities for. There are now 8, instead of 8 people, there are 7 because we're considering Mary and Francis to be sitting together. So 11p7. And inside, obviously, they can have their own arrangements also. So 11p7 times by 2. So this is 3,326,400. So all we need to do now is subtract this one from this one. So Mary Francis not together would be 1995 8400 minus 3,326,400. Okay, so 199,584,00 minus 3,326,400. This is coming out to be 6,632,000. Right, all 8 people sit together with no empty space between them, empty seats between them. Okay, so then what we will have is you will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So for example, if the first 8 people sit right over here, so 8, 9, 10, 9, 10, 11, 12, yeah, then they could sit in this fashion. Then from this one, and then this one. So we have 5 possibilities times by 8 factorial. So 5 times by 8 factorial. So this would be straightforward 201,600. All right, so that's it. All right, let's see the next question. A chess team of 2 girls and 2 boys is to be chosen from 7 girls and 6 boys. Okay, so 2 girls, 2 boys is to be chosen from 7 girls and 6 boys in chess club. Find the number of ways in this can be done if 2 of the girls are the twins and either both are in the team, both not on the team. So this is a fairly common way, a line of questioning. So both in the team So if both are in the team, that means we only need to select the boys. So 6C2, right? And both not in the team. So the boys would be, again, 6C2, but you would need two girls from five remaining girls. So 6C2 plus 6C2 times by 5C2. So this is 165 total. Right. The digits of the number 1, 2, 4, 4, 6, 8, 7 can be rearranged to give many seven digit numbers. How many of these 7-digit numbers are even? Okay, all right. So even numbers will come from 1, 2, sorry, 1, 2, 3, 4, 5, 6, 7, and you will either need 2, 4, 6, 8. So different possibilities, right? So let's do that. So at the end, let's say you have a 2, then 4, then 6, then 8. So okay, so if you have a 2 at the end, there's only one 2 over here. So the arrangement of the 6 letters now would be 6 factorial, and there are two 4s, so divided by 2 factorial. Okay. Then if you have one 4 over here, that means just simply 6 factorial, because the other 4 will be a unique 4. Then if the 6, same 6 factorial, 2 factorial, because the 2 identical 4s, again, same thing. So when you add up all of these, let's see what you get. So 6 factorial divided by 2 times by 3 plus 6 factorial, you get 1800. You can find out the values also and then add up same way. How many different numbers between 20,000 and 30,000 can be formed using different digits from the 5 different digits from the digits 1, 2, 4, 6, 7, 8. So between 200. So that would be, you could have a 2. That's it. Yeah, the number can only start with 2. So you will have 1, 2, 3, 4 after that. So how many other digits can be? 5 different digits of 1, 2, 3, 4, 5. So basically you are selecting 1, 4, 6, 7, 8. So out of 5 you need to select 4, so 5p4. Since this is a number, so arrangement will matter, so 120. Okay, Helen has some black tiles, some white tiles, some gray tiles. She places a single row of 8 tiles above her wash basin. Each tile she places is equally likely to be black, white, or gray. That means she has equal amount of black, white, or gray tiles. Find the probability that there are no tiles of the same color next to each other. So, okay, all right. So we can do it by seeing out different possibilities. So you have 8 tiles, so 1, 2, 3, 4, 5, 6, 7, 8. And for the first tile, since we don't want any one of them together, so if there are 3 choices for this one, there will be two choices for the second one. So for example, if you're choosing black over here, you can either choose white or gray. Then, sorry, black, white, gray. Sorry. Uh, then, if you have chosen white and gray, then you can either have black or the other one of these two. So basically, you still have two choices, two choices, two choices, two choices, two, two. So basically, you will need to multiply these. So 3 times by 2 raised to power 7. 3 times by 2 raised to power 7, that is 384. And this is for colors not together. Same colors not together. Okay. And since this is a possibility, we need all of the possibilities choices, no restriction choices. So this would be 3, 3, 3, 3, 3, 3, 3, 3. So this would be 3 raised to power 8. So this would be, so 6, 5, 6, 1. So the probability would be 384 divided by 6, 5, 6, 1. So 384 divided by 6561. So this would be 0.059. So three significant figures if you want to do that. So this would be 585. So basically, I think these are all the questions. Hopefully, you will see me in the next video. All right, so take care. Bye bye.